Now the smoke and gas sensor. Okay, you can see here the number of sensors like MQ9, MQ5, MQ135, MQ6, MQ8. So different type of smoke or gas sensors are using for measuring different type of gases. Okay, it's actually the metal oxide, okay, or you can say semiconductor. So metal oxide, semiconductors, carbon-based material, and conducting polymer, etc., can be used to build this kind of sensor, which is called chemi-resistance. Okay, or recently carbon nanotube also used to identify the smoke. Okay, in carbon nanotube, the it actually assembled layer by layer. So when different type of gas came, the distance between the different carbon is increased or decreased. Okay, so if we can measure this thing, a sensor can be created. Okay, very important thing is when we can build a sensor with the same material that is using for building the computing system or the embedded systems, then it will be easier to embed in our system. So you can see here the same semiconductor material can be used to identify the smoke, and in future maybe carbon nanotube is coming for building the processor. So at that time the same material can be also used for the for measuring the gas, okay, amount of gas. So actually it's a sensor that it's a semiconductor type of sensor that make the different carb for different gases. Okay, so when it creates different carb, so by measuring the carb or characteristic, change of the characteristic, we can measure which gas is present in the circumstances. Okay, so you have to read. Okay, this is not the course for teaching you the sensors. Okay, this is the course for giving you the idea how sensors work or what is happening behind the sensor. Okay, so if you have interest, you please make a deep study on this kind of sensors. Okay, how these gas sensors work, or even you can be involved with building this kind of sensors. As I told you, in this moving world or in this current technology, things are changing. Okay, so one very important issue is sensing the world or perceiving the environment. Okay, so a number of people need to work to develop different type of sensors, either by using material or by using engineering. Okay, now voltage, this is very, very simple sensors. You can see there are two resistors. Okay, by using voltage divider rule, we can sense the difference of voltage. Okay, so you just need to select two resistors, which what is the rating of one resistor 1, and what will be the resistor 2, depend on your input voltage. Okay, that means the voltage that you can use with your microcontroller. Okay, very simple sensor. Now the humidity sensor. Again, there are some material like humidity sensing component are used to sense the humidity. Again, when humidity comes, that means the amount of humidity or water increase, the sensing component change its characteristic. Okay, change the voltage difference. Okay, so by measuring the difference, voltage difference, okay, the humidity sensor can work. And the for temperature, it use NTC. Okay, NTC type of temperature sensor. Okay, so here in this sensor, two sensors actually embedded in a single board. Okay, one is humidity sensor, and that is shown in the right side pictures, and the other one is thermostat type of sensors that we discussed few slides back. Okay, so two sensors together in a single unit. Okay, I have DHT22. I think this is the model of this sensor. Maybe there are some other models also available in our country. I have forgot all the name of the sensors, but you can find it very easily. Okay, if you just if you search humidity sensor, you can find most of the humidity sensors comes with the temperature sensor. Okay, so two sensors in the single board. Now the touch sensor, I already discussed this thing, how capacitive things changed. Okay, when you okay, I have erased it. When you make two things closer, the capacity is changed. Okay, so when the capacity is changed, that means the capacitance also by feedback we are measuring the capacity. Capacity. Okay, so if the capacity is changed, that means we press something, the capacity will be decreased, and if we release something, capacity will be increased. So by using the same technique, the touch sensor can be built. Okay, like if I want to make a switchboard, like I'll just touch and the light will be turned on. I'll just touch, it turn off. So for building this kind of application, this kind of touch sensor can be used. Or you can also build your own touch sensor. You can also use IR sensor for doing this thing. Okay, now another interesting thing is accelerometer. Okay, it's totally by engineering. Okay, you can see here the inside here. Okay, you can see like one wet material is with some spring. Okay, so when you are tilting, this weight is getting tilt. Okay, so the difference is changing. The more difference, so the difference means the capacitance. Okay, oh, I have erased this thing. So when some wet thing move on right side with some spring, that means the difference, like if I just assemble like this, so when it was like this, difference was nothing, but when it tilt like this, it come closer to this finger. Okay, so when it get closer to this finger, the capacitance with this finger is increasing. Okay, and when I'm tilting in this way, it getting closer to this finger. You see, so capacitance is changing. So by measuring this capacitance, we can measure in this side tilting, or if we use the same technique for this way, then this y axis also can be measured. Okay, so by using this kind of capacity and the spring engineering, or very tiny mechanical engineering, okay, we can build the accelerometer. Also, another concept also I have told here, like if we use, one is capacitance, that means the distance increase means capacitance increase. Another way is the pressure. Like if we use piezo material here, when the piezo material get when it give more pressure to the piezo material, it give more voltage. But if in this position, no pressure. In this position, it will give pressure on this piezo material. So by measuring this thing, we can measure the tilting, okay, or in which way the things was tilted, we can measure this thing. Okay, this is the concept of accelerometer. So again, this is a very tiny engineering. This is totally by engineering. Okay, yes, we are using either piezo material or capacitance, but it's actually engineering. Okay, and excellent engineering, I think. So you can see here the concept again in this slide. Also, the concept have given, like in the colorful picture, it can measure the both position. Okay, on x-axis tilting and y-axis tilting in the same mechanical engineering, or in the same IC. Okay, so in a very tiny IC, you can see here it's 0.5 centimeter by 0.5 centimeter IC. Okay, integrated circuit, and inside this circuit, this complex engineering is built. Okay, that's why the nanotechnology came. Okay, you have to build very tiny thing inside a very small IC or a small device. Okay, so there is one field, is called nanotechnology. Okay, so those who have interest on study on nanotechnology, you can take a look, like what is the usefulness of nanotechnology here. Now, break beam sensor. Break beam sensor is nothing but, as I told you, how many times the beam is breaking. Like there is a beam, continuous beam. So how many times it's breaking? Okay, how many times it's breaking? So by measuring this thing, we can measure the speed. We can measure the distance like this. You can see here there are two things is used. One is a light source on the left. You can see here the picture. one thing on the left and two sensors on right. Okay, two sensors to measure whether it is moving forward or backward. Okay, so and you can see one is solid part, another one is open part. So when open part comes, the light goes to the sensor, but when the solid part came, the light blocks. Okay, so the light cannot go to the sensor, and since two sensors are positioned in two places, so which one blocked first? If this one blocked first, then it's moving from up to down, but if this one blocked first, then we can say it's moving from down to up. Okay, so by using this technique, you can see here the brake beam sensors is working. Okay, again, it's using just light sensor. Okay, by using a light sensor, it's calculating the rotation. By using the calculation of rotating, it's measuring the speed, it's measuring the distance. Okay, so maybe we have limited sensors, but by using these limited sensors, we have to build a number of applications. So we will be able to perceive our environment perfectly or in better way. Now this is another application of brake beam sensor. It's commonly used in our lift door, or how to say, mainly in lift door. This is commonly used. Okay, or even in some car, I also came to know recent car, they also use this kind of brake beam sensors. Okay, this is also very cheap sensors. On left side there are lights, and on right side there are either sensor or reflector. Okay, so if there is a sensor, then the light is sensed by the right side sensors. Okay, if it sends the light, that means nothing inside between these two doors. Okay, very simple technique. Yeah, and you can see just by using two sensors, okay, on the middle one, we can implement it. Okay, so but for more authenticity, or if we say a big door where not only human being but also very small things can pass. So if you want to measure that thing, the zigzag type brake beam sensors can be used. Okay, you can see here how lift door works. Okay,